All right, so we are here at the last topic for this first lesson, and I have a little bit of an example of how we can use matrices to organize data using a bit of a real-world situation. I'm going to poke fun at myself because I will confess a strange little side obsession I have with British royalty. So I have for you a little bit of a Google Trend search for you related to my favorite British royals, which would be Prince William, Catherine, Duchess of Cambridge, who I have incorrectly written here as Kate Middleton, since she's no longer Kate Middleton, but George, Prince George, and Princess Charlotte. And I have these are actual stats from Google Trends that show how often these names have been searched between April and August of this year, of 2015. And I've highlighted four major or four highlights along that. So one is kind of end of April into May, end of May into June, beginning of July, and then end of July into August. And using that information, we are going to organize that information into a chart, and then we are going to organize the chart's information into a matrix, into just one matrix. Okay, so first thing that we need to see here is that we have the way that Google Trends works is it uses the highest point, which would be here. It's a search of Kate Middleton, and it calls that 100. So this is the highest point of the searches. We call it 100, and then everything else is percentage-wise related to that and given a number value. So if Prince William here for this first section, I'm calling this A. So this is going to be time frame A, time frame B, C, and D. So in time frame A, if Kate Middleton was searched 100%, or I should say a point value of 100, Prince William was 11% of that. So he gets a point value of 11. Prince George was searched 12 times, and Princess Charlotte was searched 0 times. Okay, then moving on to section B, we have 3, 10, 5, and 3. C, time frame C, we have 5, 15, 8, and 16. And then D, we have 3, 10, 5, and 1. So this is, those are the data points that we have. Now what I'm going to do is simply move that information from the line graph into a chart. And the reason I'm doing that is because by putting it into a chart, I'm going to have the beginnings of a matrix-like organizational shape to my data. And what I mean by that is I'll have rows and columns. Of course, matrices use rows and columns. So let's give that a shot. So Prince William in time frame A had a point value of 11. In time frame B, a point value of 3. In time frame C, a point value of 5. And then in time frame D, a point value of 3. Kate Middleton was searched, we have a point value of 100 in A, of 10 in B, of 15 in C, and of 10 in D. Prince George has a score of 12, of 5, 8, and 5. And we have a score of 0, 3, 16, and 1. All right, so we can observe a few trends here. One is that Kate Middleton clearly gets the most searches of everyone in this royal family, which I guess shouldn't surprise us. She gets the most press. We also can see that of all the royals, Charlotte unfortunately seems to get the least amount of attention, poor thing. So let's organize this information into a matrix. We've taken it from a line graph, we've organized it into a chart, which makes it kind of rectangular. It gives it rows and columns, and then I'm going to create a matrix. And so I'm going to call this matrix R for royals, and I am going to give it 4 rows. And if you're wondering why, that's because I have 1, 2, 3, 4 people that I'm talking about. And then I'm going to give it 1, 2, 3, 4 columns because that's the number of time periods that I have. So all I have to do is literally move that information into the matrix in exactly the same format. So it's kind of almost brainless. All I'm doing is recopying these numbers. Now, the reason that this is important, I'm just finishing my numbers. This probably seems almost useless. And actually, I remember when I first learned about matrices, my frustration was that nobody seemed to explain to me why. Like, I understood how they worked, but I didn't understand why they were important. Until I was in college. And so I'm going to let you take a look at that. You can pause the video if you need more time to copy that down, but thinking you got the idea. I want to tell you why this is important. So I took a class in college, and the purpose of the class was to take mathematical processes that we had learned how to use and convert them into computer programs and use the computer program to solve or to model some kind of real life thing, whatever. It didn't matter what. And it was pretty open-ended, and it probably was the single hardest class I took in college because I had to understand some pretty high-level mathematics. I had to understand how to write computer programming language, and then I had to use that information to actually correctly model a real-life situation. So those are 3 pretty complex topics. So I had a fantastic professor who sat down and helped me because I wasn't exactly the computer science geek that many of the people in my class were. And so he helped me work through all of the problems, and the example that he used that he helped me to create, and I did successfully write this program, got a good grade on it too, in case you wanted to know, was to model what a cell of fluid would look like if we heated it. So that sounds kind of boring, but if you think about a pot of boiling water, if we had a little rectangular space filled with water and I heated it from the bottom, so we do that all the time on our stove, what happens is the water starts to roll. So, you know, when you hear about cooking and making a rolling boil, well, that we can actually observe in the water, that as the heat warms up the bottom part of the water starts to rise because heat rises, and it starts to move upward, and so the cold water has to pull down. So when the cold water pulls down and the warm water moves up, it starts to create a cycle of rolling, basically, within that fluid cell. So my project was to create a computer model of that kind of information where I could input into my computer program the information for any fluid. So I could make the fluid be water, or I could make the fluid be air, or I could make it be oil, something that we call very viscous. And all I'd have to do is find the coefficient of viscosity. That means how thick is it, how hard is it to move, and I'd plug it into my little equation and say go, play, and it would model the whole thing, and it would actually do it on the screen. And do you know what the center of all of my computer programming was based on? Matrices. So all of the information that was being output in my computer program was organized according to a matrix that the computer was using to organize data. So it was taking raw mathematical data and turning it into a picture that I could observe, that anybody, whether they understood the math or not, could look at and press play and see this cool cycle of how various viscosities of fluid moved around. So I'm still kind of proud about that project. It was probably one of the coolest things that I ever got to do when I was a math major. That being said, why do we need to understand matrices? Like, why organize data into this weird rectangular pattern? And the answer often comes down to it is a great way to transfer real world information into a format and a language that a computer program can understand. Another example of that is matrices resemble material in an Excel spreadsheet as well. And a lot of what we're going to learn about and how we use matrices resembles what we work with in an Excel spreadsheet. So everything about it is a little bit rigid, kind of like a program. So that's where I'm going to leave it today. We really just want to be looking at what a matrix is, how we label its size, how we assign its elements, and also how we move information from some kind of real-world context into the shape, into the form of a matrix. And we'll take up the rest of that in lesson 2.